y displacement. So just y displacement equal to 50 I am going to provide and click on build selected. So this is how you will be creating ICs. Yeah, block 4 step. Someone is asking me to repeat. So in block 4, I have created this block 4 as 15, 40 and 3, and corner point as 40 minus 50, comma 0. So once that is done, once this block 4 is created, you just need to create a copy of that block 4. That is, click on this activate selection and then select this particular IC, that is block 4. Ensure that keep input object is selected, and after that we just need to provide one displacement vector, that is in order to create one single copy of that input object. Next is I want to create one more block on the center IC. Right click on geometry and click on block. So here the width height 50, 50 and height that I am going to provide is 3. The corner point as minus 25. Similar to the central block itself, but central block the corner point was 0. Now we need to create on top of the central block. So the Z will be the should be given as 3 itself. So the x equal to minus 25, y equal to minus 25 and z equal to 3. And with this you should be able to get the geometry object which is looking like this. Now the next important part of this geometry, to create those that disk stack. And for that you might have observed we are having a cylindrical portion in the center, and then we are having the disks which are stacked on that particular cylinder itself. In order to create that geometry, that part, first we will create a cylinder. So right click on geometry and select cylinder. The radius of the cylinder I am going to provide as 5 mm. Now here in this case we can use little bit of parameterization. What I want to do is that I want to change the height of the cylinder to change dynamically whenever the number of fins of this disc stack heat sink is changing, as well as the gap between the two discs are also changing. And for that what I can do first of all is I can just define a couple of parameters. Let's say I'm first defining one parameter as air spacing, that is air underscore sp. You can give any name of your choice, but just remember that what name that you are providing, air underscore sp. And for that I'm going to provide the declaration value as 3 mm. Sorry, always the units are given in the square brackets, and the number of fins as well. So n underscore fins that I am providing, and the initial value as 10 only. N underscore fins and air underscore sp, that is air spacing. Now the cylinder height I will provide as in terms of air spacing into n fins. Okay. The position that I want to have, x equal to 0, y equal to 0 and z equal to 6. That is the center position that I am going to provide. So this is the cylinder that you can see that has been drawn. Yeah, there is one very good question, that do we need to follow any order to draw the geometry? What happens if we change the order of drawing geometry? Yes, if in some cases it may not be an issue, but for example, let's say if you are creating some composite objects, right, as I was showing earlier, and in that composite object, if you change the sequence of geometric operations, the end object will be altogether different only. So for example, if I just go back to that slide only wherein the composite object was discussed. Okay, just a second. Yeah, this is where we were discussing the composite object. So let's say that if you are how you are adding these basic primitives may not be means you can add first one block, one sphere, or first add 3 cylinders and then one what I can say, one just uh, block or so. But after that, before performing this operation, intersection operation, let's say if you directly start performing the operation like subtract one cylinder from this cube and then uh, have intersection operation with that resultant object, then you may end up having the different object, the resultant object altogether. Okay, so yes, the sequence will be important. So the parameters that I have defined is air underscore space, it is 3 mm, and n underscore fins at 10. And while creating the cylinder, I have just changed the radius as height as air underscore spacing into n fins, and the position is given as 0, 0, 6. So now let's see that if I just change the let's say number of fins as 15, you will see that the cylinder is having that asterisk, that is the settings got updated but it is not built yet. I can just click on build and you will see that dynamically it is changing, right? So as of now, I'm just going to keep it as 10. So for analysis point of view, if you want to have, you can run some parametric sweep for the number of fins and accordingly see that how the heat dissipation is getting updated. Now here in this case, for this cylinder, I want to create some selections. Okay, so this is the important part, how you can create geometric selections. So here in this case, under selections, you will see this cumulative selections option. As of now, there isn't any selection. So I cannot select contribute to. Rather, I will have to create a new selection. So I click on new and here I can just say selections as fins. Okay. We'll take another 5 minutes only to finish this exercise. So hope all of you are okay with that getting extended. So this is the fins that we have created, and after that is created, if I just click on build selected, you will see that the cumulative selections are appearing over here. Now you will see that just as of now, just the cylinder is created and its corresponding boundaries, edges are having different sets of selection. That is one selection for boundaries, one selection for edges, one selection for corresponding points that also have got created. Now let's add those fins itself. So for that, what I'm going to do is I'm going to create a work plane first. Sorry, right click on geometry and create a work plane. Here in this work plane, I'm going to create a select a face parallel. Now why I'm selecting a face parallel, and in that face parallel, I'm going to select this top surface of this block 5. So whenever we are selecting this face parallel work plane option, right? After that, if you go to plane geometry, the center of that plane will get aligned with 0, 0, local 0, 0 as well. So for example, if I wanted to get aligned with the center of this block, I just created a face parallel for this surface. If I wanted to create some object which is centered at this particular IC, I would have selected the face parallel option for that particular surface only. So that even though both of them are in the same plane, the center will get moved, that 0, 0 will get moved from this point to this point. And hence it is always easier to use face parallel when you know that you want to have that centered at the center of the work plane itself. So now here in this case, I am just the very first thing is that I do not want to have that work plane at aligned at the same surface. I want to provide that spacing as an offset. So it is air underscore sp. That is the offset that I am providing. Now, if I right click on this plane geometry, I will create one circle. And the circle radius that I'm going to provide as 5 mm, which is centered at 0, 0. Click on selected. Then another circle that I'm going to create with radius as 25. I do not have to worry about that different coordinates, that is 40 comma minus 50, because now everything is at 0, 0 as I have used face parallel option. So 25 comma 0, 0, sorry, 25 and 0 comma 0. We need to take a difference, that is booleans and partitions. Difference operation, this is the bigger object, and from that I want to subtract a smaller cylinder. By just using scroll button, I am just selecting that inner object and clicking on build selected. Okay. Now here again, go back to that work plane 1. You can click on build selected. You will see that the first fin is created. But we want these fins also to get added to the selection. So locate this, contribute to, select the selection that you have created earlier. But we want to have those stack of these fins, right? Hence the last operation that we want to have is go to geometry node, under transform, you can see an array option. Okay. In that array option, I just need to select this work plane object. Rather than providing 3-dimensional array, I just want to have the array in the Z direction only. So I just will select the linear array option and the number of fins, that the parameter that we have already defined, that is n underscore fins, right? And the displacement in X and Y direction, definitely we do not want to get any displacement. Only in the Z direction we need to have a displacement. So we are going to have displacement as air underscore SP. And here again, before I click on build selected, I will ensure that I am adding it to the fin selection. So whatever the array objects that are getting created, that will also get added to the selection. And this is how you can see the this disk stack has been created. The example model that has been discussed in the application library, over there you will see that how the model problem was solved with and without having that disk heatsink as well, and what are the effects that it is having on your model. Just a second, I will just open that model also to show you that how the results are varying. Yeah. Yeah, for the array, you need to right click on geometry, then go to transform and select array. In that array, select in this array, you just need to select the option of first of all, select this input object as work plane object that you have created as a circular object. After that, as we want to have that array to grow only in the Z direction, I have selected linear array. By default, it was 3-dimensional. I have selected linear array. And then I have just provided the displacement vector. That is the displacement in the Z direction. That is the air underscore SP. That is the spacing that I want to have between two fins. And with that, while creating this array, I have also added that it should contribute to this fins selection as well. So that whatever the object that has been getting created through this array operation will get added to the cumulative selection as well. So this is the example model which is available in our application library as well as in application gallery. And here you can see that the heat transfer in solids that has been solved on the PCB as well as on all ICs. Whereas The heat transfer in shells, it is solved for the stack itself. And here you can see that the selection that we have used, that is the boundary selection which has been created from the geometric operations itself. And here the temperature has been calculated with and without having the disk stack heat sink. So this is the temperature that you can see how it is changing or how it is reducing when you are having the multiple fins added. So this was about the today's session. Hope you found the session useful. Before I hand over the session to Anushka, I would like to discuss today's assignment also with you. So for the geometry assignment, this is the password. Anushka will also share this password when she is going to share the recordings with you. But before that, if you want to access the assignment question, please note down this password, that is GOM, G is capital, 36, JH. Both these things are, J and H are capital. So this is the password, but that will also be shared with you separately. So the objective of this assignment is to get the geometry which is shown in this slide. That is the kind of a circular disc kind of structure wherein we are having some holes created also. So you need to create this geometry and compute the volume. In the assignment, we will be checking what is the final volume that you are having and what are the steps that you have used to create the geometry, whether you have used the optimal number of steps or not. So in order to create this geometry, just observe that what is the top view and what is the bottom view. Top view, you can see that there are through and through holes, circular holes, and at the same time we are having some grooves, circular grooves also over here. Now at the bottom view, you do not see those holes. Those are not the through and through holes. So the very first thing is that you will need to see that how you can get such kind of objects. Next is from the side view, you can see that certain fillet has been used. The fillet radius is also given, that is 1 mm. So you will have to provide the fillet also. Next, for the spherical objects which are used over here, we have provided the dimensions for all the necessary objects. For a few, you may need to back calculate based upon the dimensions provided over here. So the dimensions provided the dimensions, please create the geometry and then upload your COMSOL model file to the app in order to check whether the finalized geometry that you are having is created with the required number of steps, as well as if it is having the required volume or not. So that's all for today from my side. I know that there are a few questions that we could not answer them in today's session. Please feel free to come for tomorrow's one-on-one session as well at 3 o'clock, wherein we can discuss if you are having any questions left unanswered today, or if you might have faced any problems while attempting the assignment that has been submitted today. Okay, thank you. Just one question, what is the need of using work plane? Well, if you are referring to the previous hands-on problem that we were creating, with work plane we could create that circular surface which is aligned exactly to the what I can say exactly at the center of the center IC. Additionally, whenever you want to create any 2D object in the 3D work environment, in that case you will need to use a work plane in order to create any 2D object, and that's why the work plane was used. Okay, so yeah, Anushka, over to you.
Thank you, Prajakta, and thank you, everyone. So basically, before we wrap up this session, I would like to mention that this session is recorded, and I'll be sharing the recording of this session after this particular session. And also, I'll be sharing this passcode with you to access the geometry assignment. Okay, and yeah, so whatever questions, if you feel that are left unanswered today, please join us tomorrow for the question and answer session at 3 p.m. IST. Okay, so thank you everybody. Thank you Prajakta. And also just one more thing, ensure to submit your assignments by tomorrow 2 p.m. IST. I'll also be sharing that information with you in my email. So yeah, thank you everybody. Thank you Prajakta.